Okay, right now I would like to explain also something about statistics, probability, random variables, this subject. Trying to explain the difference between y is equal to x squared or y is equal to x times, z is equal to x times y. Okay, what are we talking here? Let's assume we have two random variables that are exactly the same. They have the same distribution. Let's use the most simple case, that is uniform distribution that goes from 0 to 1, and it is that f of the x is always 1. That is, we have two of such distributions. Now we would like to know x squared. We want to take this distribution and make a new one, create something that the new distribution is called y is equal to x squared. What does that mean? It means, in the most simple language, it means like this: whatever you get in the first distribution by x, you would get now in the y distribution in x squared. So let's say that in the original distribution, from a half till 1, there was actually a half, 50% of the distribution, because that's a uniform distribution. It gets from a half to 1 exactly a half of just 50% of the distribution. Here, what is a half squared? A half squared is a quarter. Here you must have, and 1 squared is 1. So here you must have, from y is equal to a quarter till y is equal to 1, you must push in half of the distribution. That's the rule. Another example. In the original distribution, from x0 till x is a third, we had a third of the area, because it's a uniform distribution. So from 0 to a third, we are covering a third of the ground. Here we must cover that ground from by the y distribution. It must be covered from a 0 till a 9th. I'll make a diagram for this. It should be clear. The top one is the x. As you see, it goes from 0 to 1, and it's very simple, it's uniform. So the shaded area is what is covered from 0 to the third. However, we must squash in all of this from 0 to the 9th when you get to y. Y is equal to x squared means that whatever you get to cover ground that gets covered when x is a third gets covered here when y is a ninth, when y is x squared. So here we must cover the ground much faster. So obviously it's going to be higher up in order to cover that ground. We can't keep it just by 1 inch high. We must make it at least 3 inches high, or certain areas at least. We must make sure to cover that ground of a third. Obviously, when they reach 1, they both cover the same ground, namely 1, because every single distribution in the world covers ground of 1. But the difference is at which point does what percentage get covered. Here, by the y, the x squared must be covered. I'm sorry, the amount that is covered by x is equal to little x is covered here when y is equal to little x squared. This is one thing, and this is not so hard actually to figure out distribution of y. It can be done quite easily, and I'll do it for you. I'll make for you the way how to do it. So f of y is equal to f the root of x, the root of y. What is the f of y? How much ground is covered when y is equal to something? The answer is I should have written a second f here, sorry. F of y is equal to the root of y. As you see, when y is, for example, let's say y is a ninth. So how much ground is covered by a ninth? The answer is the root of y. That is, the root of a ninth is a third. How much ground is covered when y reaches a quarter? The answer is the root of a quarter, that's a half. So when y reaches a quarter, when y reaches a quarter, we have already half of the ground covered. That is, the root of a quarter is a half. This is the rule of this function. Y is equal to x squared. It's actually taking the opposite. We're taking the reverse function of y is equal to x squared, and that is the root of y. X is equal to the root of y. Anyway, this is how we do it. And once we know already the capital F of y, we just do the derivative of that to find out the little f of y. And then by the root of y, we know the derivative of that is y negative a half, and that is, I'll write it down at the bottom. A half times y negative a half, that is the f of y. So it's quite simple, and it's not so troublesome to get to the bottom of this distribution. Sometimes it can be a drop harder, but basically it is simply converting this function into a different into x squared. Y is equal to x squared, and that's how you find out the new distribution. However, we can do something totally different. That is, instead of making y is equal to x squared, we'll do y is equal to x1 times x2. What does that mean? Okay, that is what we said in the video before. Y is equal to x1 times x2. What does this mean? It means we want to create a function that deals with this two-dimensional plane. Because again, you have to understand that we could deal with a two-dimensional plane. When we said y is equal to x squared, we just dealt with a one-dimensional. Here we're dealing with a two-dimensional plane. It has two axes. One is called x1 and the other one is called x2. And we're trying to figure out this new function so let's assume we want to have y is equal to a half. That will mean all the points where x1 times x2 is equal to a half. That shows all the points of this xy plane, or I shouldn't use xy, x1 and x2, where x1 times x2 is equal to a half. And obviously, the shaded area will be all the points where x times y is a half or less than a half. So, if we could figure out what is that function, this f of the z, of the big Z, that tells us at any given value z can be from 0 to 1, because any number here, x times y, can only fluctuate between 0 and 1. So if you can figure out what is the f of the z, that will teach us at every single number z, what is the area of this that gets covered. Then we take the derivative of that, that gives us the f of the z. Totally different. It's much more complicated. It comes out to be the natural logarithm of z. That's the f of the z. So there's nothing to do with the thing we saw before. You could confuse them, because it sounds like you're saying y is equal to x1 times x2, and isn't x1 and x2 the same? So if they're the same, you could say it's just x squared. It's, it somehow has the same rhyme, at least in my opinion. So it's one of the things that might be well be confused. So you have to keep guard in this, to understand these are totally different operations, so to speak, different operations. In the first one, we take the x. We just have an x1x. There's no two-dimensional stuff flying around. Simple x, and we sort of stretch it out. Or actually, in this case, we don't stretch it because it only goes from 0 to 1. if we go, let's say, from 0 to 2, then we stretch it from 0 to 4, and all the areas that are involved in the x's are now involved in the x squareds. So they take up that space in a lesser place. If it's from 0 to 1, it squeezes in a tinier area. If it's after 1, it has more room to expand. That's what happens here. By this second case, what we do is we're dealing with a two-dimensional place that goes we have like x goes from 0 to 1, x1, x2 goes from 0 to 1. We're trying to figure out all the points where the x1 times x2 is a certain number or less. For example, a half or less, a third or less. And that will be the new capital F of z. That will teach us what is the distribution, the cumulative distribution of f of z. All the points where the area, the total amount of volume, where the points of this two-dimensional graph are, if you multiply them, are a third or less than a third. Anything less than a third. So I'm just saying an example. A third could be a quarter, whatever it is. That's the f of the z. Depends which number, which z you're using. Obviously, end up with a total different picture. Get different distributions. Only thing that's the same, that's why it's confusing, is that it starts, both of them start by 0 and by 1. Start and end by the same number, because x times squared is x times x, and also x1 times x2 is also the same number. So they both are going to have the numbers in this interval from 0 to 1 or from 0 to 4. For example, let's say if you start off originally with x as a distribution that goes from 0 to 2, and then you have another one that goes also from 0 to 2. So again, we have the same thing. We can look at it like x squared, or we can view it as actually getting this two-dimensional business here flying around and saying, let's take all the points where x1 times x2 is a certain number, and let's see what area it covers, or what volume it covers at that point. That is the story of this whole business. And to get some examples, concrete examples, I think we'll have to wait for the next video. Thank you very much for listening. Enjoy.